What was the question? So I gave you a problem saying a particle is projected from a particular place and it should be projected in such a way that it is hitting the target at a distance of 25 meter. And with what velocity it should be projected? It should be projected with a velocity of 15 meter per second. I asked you what should be the angle of projection. So the angle of projection, for finding it, we applied the formula of range and then we proceeded. R is equal to u square sine 2 theta divided by g. That is, by substituting all the values, we get sine 2 theta is equal to 10 divided by 9. You remember till this step, right? So what will be the answer? What will be the angle? So what is the answer? See, if sine theta is equal to 1 by 3 means you can write theta is equal to sine inverse of 1 by 3. In a similar format, how do I write sine 2 theta is equal to 10 by 9? 2 theta I can write it as
sine inverse of 10 by 9.
Sine inverse of 10 by 9 and theta will be equal to, this 2 will go to the other side. 1 by 2 into sine inverse of 10 by 9. This is the answer, right? So when they ask you about the angle, you need to report it like this. Is this clear till this step?
Yes, sir.
But the answer is wrong. Can someone tell me why the answer is wrong?
So how will you cancel, sir?
What did I cancel? I didn't cancel anything.
How will you take that one to you, sir?
It is not because of that. The step itself, there is a mistake. So think in terms of trigonometry. So what has happened here?
Hypotenuse is smaller.
That's right. Very good. So hypotenuse is smaller means that's a very good logic what you told. Good. See, what is the maximum value that sine can generate? Maximum value of sine theta is +1. Okay. So, but what is this value?
More than 1.
It is more than 1. Since sine of 2 theta is greater than 1, you should report the answer like this. There is no angle of projection. There is no angle of projection for which the particle will be able to hit how much distance? At a distance of how much value, guys?
25 meters.
25 meters. So in this case, it is not possible at all. Is it clear? So you need to be very careful. Just because you got sine theta is equal to something, don't say that is the answer. You have to check whether sine theta is greater than 1 or not. I mean less than 1 or not. So the maximum value of sine theta is +1 and the minimum value of sine theta is -1. Okay. So is this clear? So keeping this point in mind, we'll proceed to the So write down the heading as maximum range possible. So the heading itself is maximum range possible. Okay. So R is equal to U square. What is the formula? R is equal to U square sine 2 theta divided by G. Okay. This is the formula for range. Now who is going to decide the maximum range? So range will be maximum when sine 2 theta is maximum, right? So what is the maximum value of sine theta? Since
1.
Since maximum value of sine 2 theta is equal to 1, so what angle of sine will give you 1?
90.
90. So can I write 2 theta is equal to 90 degrees?
Yes, sir.
Then what is the value of theta? Theta should
45
be
degrees.
45 degrees. This is a very, very important point to be kept in your mind. So when a projectile is released at an angle 45 degrees with whom? With the horizontal or vertical? All the derivations, where did we take the angle as? So when a projectile is released at an angle of 45 degrees with the horizontal, what can we conclude?
Range will be maximum.
Yes. This is an often asked question. So what they will do is they will not say that the angle of projection for this case is 45 degrees. What they will say is if a projectile is released in such a way that it has the maximum possible range. Okay, at the time, what have they given you? They've indirectly given you the angle of projection. Okay, while solving the problem, these are all very important concepts. Is this clear?
Yes, sir.
Yes. So make a note of it. Then the next heading is angles of projection for which ranges are equal. So now what we are going to do is we will see what are all the angles of projection for which the ranges are going to be equal. Okay. The meaning of this is if you project a particle, let's say with speed u at an angle theta, let us say it is going and hitting the horizontal distance at a value r from the origin. Okay. With the same angle of, with the same velocity of projection u, instead of theta, let us say there will be another angle alpha at which you try to project the particle, it will go and hit the same range r. Now our work is to find what is the relation between this theta and alpha. So that is what the meaning is. Angles of projection for which the ranges are equal. One important point to be noted here is initial velocity should be the same. Clear? Now see what I'm going to do is now see case 1 and case 2. So in the first case, what is the value of r? R is equal to u square sine 2 theta divided by g. In the second case, what is the value of range? Can you tell me? It is same u square sine
Alpha.
2 alpha divided by g. So 1 is equal to 2. Right? That's what the heading is. The range should be the same. So u square sine 2 theta divided by g is equal to u square sine 2 alpha divided by g. So u square by g will get cancelled, which implies sine 2 theta is equal to sine 2 alpha. Okay. So sine 2 theta is equal to sine 2 alpha is possible in two circumstances. One is when 2 theta is equal to 2 alpha, or when 2 theta is equal to 180 minus 2 alpha. The reason being, sine in the second quadrant is going to be positive. So sine 2 theta is equal to sine 2 alpha is same as sine 2 theta is equal to sine 180 minus 2 alpha. So if I take these two cases, then I can write 2 theta is equal to 2 alpha. If I take the first and the third case, then I can write it as 2 theta is equal to 180 minus 2 alpha. So from this, what I can conclude is either theta has to be equal to alpha or theta has to be equal to. So from this case, what will I get? Theta will be equal to 90 minus alpha. So what is the meaning of this? That theta and alpha should be complementary angles. So if theta and alpha are complementary angles with the same velocity of projection, then the range attained by both the particles would be the same. Is this clear? So these are all very important concepts. Make a note of it.
Sir, can you show the graph again?
Yeah, sure. There's X, there's Y.
Thank you, sir.
Okay. You're done?
Yes, sir.
Okay. Next. So these are all the concepts. And the next important point related to projectile motion is the equation of projectile. So in this equation of projectile, means what we are going to do is we will try to define the motion of the particle in terms of X and Y. See, suppose I project the particle like this, then it is going to travel in a path like this, right? So till now we didn't discuss what is the shape of this path. Can someone tell me what shape does it take? What is the shape actually?
Semicircular.
It is actually parabolic. It is not a semicircle. Maybe my diagram is looking like this. Sometimes if you project it like this high, it will go like this and come. This is not a semicircle. This is a parabola. Okay. So in your 10th standard, you would have learned. Where did you learn parabola? You have heard this word, I'm sure.
Polynomial.
Polynomials.
Is it polynomial or quadratic equations?
Quadratic equations.
Then the quadratic equations you would have learned, right? So second degree equation, ax square bx is equal to 0 represents what? See, even in polynomials it is right. You would have written it as
General form of an quadratic.
y, that's it. Sorry? So ax square plus bx plus c represent, you would have heard of these two terms, right? It represents an upward parabola. It takes a shape like this. If the value of a is greater than 0 and discriminant is greater than 0. Right? As of now, let's forget about discriminant. Let's not go according to it. Let's not worry about the discriminant. So when do you call it as an upward parabola? When the value of a is greater than 0. Okay. You can call it as a downward parabola when the value of a is less than 0. Right? So what is a according to the equation? A is nothing but the coefficient of x square. Is it clear to this step? Is it clear or not?
Yes, sir.
Okay. So what I'm going to do is, I'm going to derive the equation of this, equation of the path followed by the projectile. So that's what is called as equation of projectile, and this is also very, very important point. Okay. So if I take this angle as theta, then what you have, this will be u cos theta, and this will be u sin theta. All right, this point is clear. Let us say at some time t, the particle particle is at a coordinate of x comma y. So what I'm doing is at some instant t, let's say the particle is at a point. The particle is at a point p x comma y. Right? So if I drop a perpendicular, then what is this distance equal to? So this is 0, 0. So what is the distance from the origin to the foot of the perpendicular drawn here?
X.
It is x. Similarly, what is distance equal? This
Y.
distance, right? So this distance is y. So what I'm going to do is all this is happening at the same instant t. So at the same instant t, the particle is having x coordinate and its corresponding y coordinate as well. Okay. Now what I'm going to do is applying s is equal to ut plus half at square along x direction. So if I apply s is equal to ut plus half at square along x direction, sx is equal to ux into t plus half into ax into t square. Right. So what is the displacement that has taken place for the particle along x direction?
X.
So x is equal to, what is the initial velocity of particle along x direction? You have it. Very good. It is u cos theta into the time it takes is t plus half into what is the acceleration of the particle along x direction? We discussed it yesterday. Just check your notes, you'll get the answer. Acceleration of the particle along x direction.
G.
Along x direction, guys.
0.
It is 0. Because there is no air resistance, no. Yesterday I told you this point. So it will be 0. So x will be equal to u cos theta into t, which implies t is equal to x divided by u cos theta. Let this be equation number 1. Similarly, applying s is equal to ut plus half at square along y direction, what do you get? Sy is equal to uy into t plus half into ay into t square. Right? So what is the displacement of the particle along y direction now? Look at the diagram, you'll get the answer.
U sin theta.
So displacement of the particle,
Y.
it is y, that's it. Y is equal to initial velocity along y direction,
Sin theta.
it is u sin theta, into t plus half into acceleration along y direction is,
Minus G.
it is minus g into t square. So y is equal to u sin theta into what is the value of t? T is nothing but x
by
divided by
u.
u cos theta. So x by u cos theta minus g by 2 into x by u cos theta the whole square. Right? So u and u will get cancelled. Y is equal to x is outside, sin theta by cos theta, tan theta, minus g by 2 into x square divided by u square cos square theta. Got it? So y is equal to x tan theta minus g x square divided by 2u square cos square theta. So this is the equation of projectile. Now tell me one thing, what is the coefficient of x square here? It is g divided by 2u square cos square theta. Is it positive or negative? Look at this expression. What is the coefficient of x square? G divided by 2u square cos square theta. Sorry? I didn't get you. Is it positive or negative?
Negative.
It is negative. So what did I say? When you have a polynomial, ax square plus bx plus c, if the coefficient of x square is less than 0, what parabola does it represent? It represents a downward or an upward parabola?
Down.
It's a downward parabola. That is why if you look at the way the particle is moving, it is moving in a parabolic shape. That is a downward parabolic shape. Are you able to understand? So the way I've drawn the diagram tells me that the particle is moving in a downward parabolic path. But if they ask you generally what is the shape of the path followed by the projectile, you just need to say it is parabolic. That's it. Okay? So I can make a note of it. Okay. So let me know once you're done. So till here only it is as for the exam. All this explanation is for your understanding.
Sir, could you go up?
Even more?
No, this is enough, sir. Done, sir.
Yeah. So with this, projectile motion is over. Okay. So the concepts that are left out are relative velocity in 2-dimension and uniform circular motion. So these were simple concepts only. So before we proceed to that, let us do some problems. Okay. So you're able to see the sheet?
Yes, sir.
Okay. Now listen. So the sixth question is, in a projectile motion, if the maximum height capital H is half the range, okay, I'm repeating it again. In a projectile motion, if the maximum height H is half the range, that is, capital H is equal to R divided by 2, then what is the angle of projection? So this is worksheet MCQ, the problem number 6. What is given? The maximum height is half of the range. The angle of projection is equal to what? So how to solve this? So what you can do is, what is the formula for maximum height? U square sine square
theta by 2g.
By 2g is equal to 1 by 2 into the formula for range is u square sine 2 theta divided by g. So what will get cancelled? U square, G and G, 2 and 2 are gone. So sine square theta is equal to 2 sine theta into cos theta. Okay, what can I cancel on either side? One sine is gone. So tan theta will be equal to 2. So how can I write theta as? Theta will be tan inverse of 2. Did you understand? So tan theta is equal to 2, which implies theta is equal to tan inverse of 2. So let us check the option. So the option is second one, tan inverse of 2. Any doubt in this? Right. Let's do the seventh one. So the question is, an object is projected with velocity v bar. If the range r of this object is double the maximum height, so range r of the object is equal to 2 times capital H. It is similar to the previous problem. So in the previous problem, they have given H is equal to half r. Now they are giving r is equal to 2H. Both are same. Okay, I'm repeating it again. An object is projected with a velocity v. If the range r of this object is double the maximum height, then its range is equal to. So how to solve this? 7th, since r is equal to 2h, on solving this, you will get tan theta is equal to 2. I hope there is no doubt in this step. Right. Since r is equal to h, tan theta will be equal to 2. What have they asked? R is equal to u square sine 2 theta divided by g. The angle of projection is given as v. So v square by g is g only. How can I write sine theta, sine 2 theta? It is 2 sine theta into cos theta. Okay. It is v square divided by g into 2 into. When tan theta is equal to 2, what is the value of sine theta? Tan theta is 2. So 2 divided by 1. So what will this value be? Root 5. Right. When tan theta is 2, what is the value of sine theta? It is 2 divided by root 5 into cos theta is 1 divided by root 5. So what do you get in the numerator? 2 into 2, 4v square divided by root 5 into root 5 is 5g. So this is going to be the formula, the expression for range in this particular question. It is 4v square divided by 5g. One minute, I'll send this question paper to you in 2 minutes. Just taking some time. Leave. I'll send it today. It's taking time. Leave. Okay. Now let's do the next question. So 4v square divided by 5g is the answer. Similarly, look at the 10th one. You people try. For which angle of projection the range and its maximum height will be equal? So what should be the angle of projection for which the range is equal to maximum height? You guys do and tell me. So the answer. So what is the answer?
Tan inverse 4.
Inverse 4.
Tan inverse 4. That's right. So when R is equal to H, what will you get?
ரொம்ப நேரமா காணுமே அம்மாவும் இல்லையான்னு பார்த்தேன்.
When R is equal to H, it is u square sine 2 theta divided by g is equal to u square sine square theta divided by 2g. This and this will get cancelled. So u square is gone. 2 sine theta into cos theta is equal to sine square theta. So 1 sine theta is gone. Tan theta will be equal to, so tan theta will be equal to 4. Theta will be tan inverse of 4. So what is the question number? 10. So this is an easy one. Next. 15th one. So all these are projectile motion based problems. So 15th one, what is it? When the angle of projection is 25 degrees, the range of the projectile is capital R. Now what should be the angle of projection for its range to remain the same? I already told this point to you. So the range will be same if the angles are
Complementary.
complementary. So what should be the answer?
5 degrees.
65.
Sorry? It is
5 degrees.
65. Yes. So answer will be 65 since angles should be complementary. That's the reason. Okay. Next. 17. The acceleration of a projectile at its maximum height is. So, when theoretically speaking, when the projectile is moving, what is the only acceleration it is experiencing? Acceleration along acceleration along x direction is 0 and acceleration along y direction is
Minus.
g. It is minus g according to the sign. But they're asking what is the acceleration of the projectile at its maximum height. So what is going to be the magnitude of it?
Gravity.
G. That's it. That's the answer. Okay. Next. 18th one is, an object is projected at an angle of 45 degrees with the horizontal with kinetic energy K. Its kinetic energy at maximum height is how much? An object is projected at an angle of 45 degrees with the horizontal with kinetic energy K. What will be the kinetic energy at the maximum height? So I will do this problem. Observe. So the 18th question is, there is a particle which is projected at an angle of how much value? Theta is equal
45.
it is projected at 45 degrees. Let's say its speed is u. Speed is not given. Observe the problem here. So instead of speed, what have they given? They have given you the kinetic energy of the particle. So what is the initial kinetic energy of the particle? It is half m u square. Let this be equation number 1. Right. So let this is what is given. No, kinetic energy initial is what is given as capital K. So let this be equation number 1. Let the kinetic energy at highest point be K dash. Okay. Then what will be the value of K dash? K dash will be equal to half into m into whatever is the velocity here, velocity square. Highest point, what is the only velocity the particle has?
Horizontal velocity.
It is horizontal velocity. If u is the velocity with which it is projected, what is the horizontal velocity? It is u cos 45.
Cos theta.
And vertical velocity is u sin 45. So what will this value of v be at the highest point? It is u.
U cos 45.
Very good. It is u cos 45 degrees. So it will be u divided by root 2. All right. So kinetic energy at the highest point will be half into m into v square. That is u square divided by 2. Since at highest point it has only horizontal component of velocity. Right. So half into m into u square means I will take one half. It will be half into m into. See, listen. I'll take 1 by 2 outside. So if I take 1 by 2 outside, it is half into half mu square. But what is value of half mu square? It is capital K. So this will be equal to K divided by 2. So what is the value of K dash? The kinetic energy at the highest point will be half of its initial value. Are you able to understand this?
Yes, sir.
Yes. Okay. Next. The 20th one. Bullets are fired with same initial velocity v in different directions on a plane surface. These bullets will fall on the maximum area of how much value? Okay. So 20th one is, bullets are fired in all the directions with how much velocity? With same initial velocity v in different directions on a plane surface. These bullets will fall on a maximum area of how much value? So for you to attain the maximum area, so the maximum area will be pi r square. Okay, the maximum area will be pi r square, where r is the range. So when can the area be maximum? Area will be maximum only when r is maximum. When is r maximum?
Theta is 45.
That's it. When for area to be maximum, r should be maximum. And it is possible at theta is equal to 45 degrees. When theta is equal to 45 degrees, r is equal to u square sine 2 into theta, that is sine 2 into 45 divided by g. So u square sine 90 is 1, u square by g. So this is going to be the formula for maximum range. Then what will be the maximum area? Pi r square. What is r? U square by g the whole square. So this will be pi u power 4 divided by g square.
Sir, maximum area is denoted by what, sir?
Maximum
Maximum area is denoted by which alphabet, sir?
maximum area is I didn't get you. Maximum area means
Maximum area is denoted by which alphabet, sir? For range it is R. For maximum area, sir.
you are asking the symbol. Huh?
Yes, sir.
There is no symbol and all because it's a particular question. Generally, we don't study about area. It is only a particular question where the area is asked about. You can just, if you want, you can take it as capital A. That's it. So let me know once you're done. Here, right? We'll go to the next problem. So pi into u power 4 divided by g square is the answer. Now look at this problem. For the 21st one, for a projectile motion, y of t is equal to 8t minus 5t square, x of t is equal to 60, where x and y are in meter and t is in second. So what they have given us, y as a function of time, x as a function of time. So the initial velocity of this projectile is equal to what? Okay. Someone note down the equation. Y is equal to 8t minus 5t square and x of t is equal to 60. They're asking the initial velocity. Tell me, what is the question? Number is 21. So y of t is what?
80 minus
minus 5t square.
80 minus 5t square. X of t is 60.
60.
Right? Right. So x of t is 60. Now they're asking the initial velocity. How to do this? So how you can proceed is observe. From 2, I can write t is equal to x divided by 6. 1, 2. Okay. Let this be 3. I will use third equation in the first equation. Then y will be equal to 8 into x divided by 6 minus 5 into x square divided by 36. Is this clear? So y is equal to x into 4 divided by 3 minus 5 divided by 36 into x square. Any doubt till this step?
No, sir.
Right. So what is the equation of projectile? We know that. You can refer and tell me for today. We know that the equation of projectile is y is equal to x tan theta minus g x square divided by 2u square cos square theta. Am I right?
Yes, sir.
Okay. So I'll tell you an alternate method also to do this. Now what you can do, you have two equations in your hand. So 4 and 5 represent the same. Yes or no? The fourth equation and the fifth equation represent the same. Since fourth equation is equal to fifth equation, what is tan theta equal to? So comparing both, what
4
do I
by
get?
3.
4 by 3. Similarly, g divided by 2u square cos square theta is how much?
5 by 30.
5 by 36. In this question, you can take the value of g as 10. So if you take g as 10, so 10 divided by 2u square into, if tan theta is equal to 4 by 3, then what will cos theta be equal to? Draw the triangle and tell me.
3 by 5.
Very good. So cos theta will be equal to 3 by 5. So u square, cos square 45 means it is 9 divided by 25. Correct? 9 divided by 25 is equal to 5 divided by 36. So this will go 5 times. So 5 and 5 will get cancelled. So u square, 9u square divided by 25 is equal to 36, which implies u square is equal to 100. So what will be the value of u? 10 meter per second. So the initial velocity of the object in this case is 10 meter per second. Just give me a
Where
minute.
did the x square go, sir?
Sorry.
Where did the x square go, sir? X square. Gx square minus 2 u square cos square theta.
Compare this and this.
No,
What
sir.
will you get?
Yes, sir. Yes, sir.
What is it? This is clear. U is equal to 10 meter per second. Okay. If you're done with this, I'll teach you the alternate method also.
Yes, sir.
Yeah. So look at the alternate method. So before I explain this, recollect parallelogram law of vectors. If A bar and B bar, A vector and B vector are two co-initial vectors with an angle theta between them, then how is the resultant across? So R will be along the diagonal joining, along the diagonal of the parallelogram, and its initial point will be from the same initial point across which A and B are starting from. So R will be equal to root of A square plus B square plus 2AB cos theta. You guys remember this?
Yes, sir.
So R is equal to root of A square plus B square plus 2AB cos theta. So according to this question, y is equal to 8t minus 5t square and x is equal to 60. So y is the displacement, x is the displacement. Okay. If I do dy by dt, what do I get? Rate of change of displacement is what?
Velocity.
It is velocity. So dy by dt is equal to 8 into derivative of t is 1. Right? Derivative of 8t is 8 minus, what is the derivative of 5t square?
10t.
10t.
Okay. Similarly, what is t equal to?
6.
6. Now, if you observe, velocity is also a function of time. This is 8 minus 10t. Here, the velocity is a function of time, that is 6. But the only difference is here, it is a velocity in x direction. Here, it is a velocity in y direction. Okay. So, where have they asked the velocity? Velocity at initial point. So at initial point, what is the value of t? At initial point, t is equal to. So what is the initial time always? What is that we take?
0.
0.
0. So initial time is 0 means Vy at 0 will be equal to 8 minus 10 into 0. What will it be? It will be 8.
8.
Vx along 0 will be 6 only, because here velocity is not a function of time. Here you don't have time. Right? It's a constant. So can I say the velocity along x direction is 6 and the velocity along y direction? To ignore this other, they are perpendicular. So what will be the resultant velocity? Resultant velocity will be root of Vx square plus Vy square plus 2 into Vx into Vy cos of how much angle? What is the angle between these two?
90.
90.
So Vx square plus Vy square into cos 90. Cos 90 is going to be 0. So
0.
V will be equal to root of Vx square is 8 square plus Vy square is 6 square. I swapped and wrote it. So it is root of 8 square plus 6 square, that is 36 plus 60. Sorry, 64 plus 36. It's the same. Are you able to understand?
Yes, sir.
So whichever method is comfortable, you can take it. Write it down. So if you're done with this, we'll go to the next problem. So mark this problem as important. Okay. So this is the projectile motion based problem. Now listen. Let's do the 23rd problem. Two objects are projected with the same velocity at different angles with the horizontal. And if the range is same for both, then prove that T1 into T2 is equal to 2 into capital R divided by G, where T1 and T2 are the time of flights. This is also a good problem. Mark it as important. So two objects are projected with the same velocity at different angles with the horizontal. And if the range is same for both of them, prove that T1 into T2 is equal to 2 into capital R divided by G. Okay. So one important point to be noted, they're projected with the same velocity at different angles with the horizontal, and the range is same for both. So when is it possible? Only when both the angles are. When will the range be the same? Complementary. So the 23rd problem. This is in the solve the following distance. So 23rd one, what they are saying, the range is same and U is also same. So the angles of projection will be theta and so if one of the angles of projection is theta, what will the other angle of projection be?
90 minus.
90 minus theta. So what is the value of T1? T1 is 2u sine theta by g. Then what will T2 be? 2u sine of, in the place of theta, what should I write? 90
Sine
minus
90.
theta divided by g. Am I right? So this will be equal to 2u into sine 90 minus theta is nothing but cos theta divided by g. So T2 will be 2u cos theta divided by g. So first and second, what did they ask? They asked the product of the time of flight. So T1 into T2 will be equal to 2u sine theta into 2u cos theta the whole divided by g square. Right? So 2u into 2u will be 4u square, but I'll still write it as 2 into 2u square sine theta into cos theta the whole divided by g square. Okay. So what is 2 sine theta cos theta?
Sine 2 theta.
Yes. 2u square sine 2 theta the whole divided by this g square I'm going to write it as g into g. Okay. Now observe. What is u square sine 2 theta divided by g? What is u square sine 2 theta divided by g?
Max height.
It is a range. U square sine square theta is maximum height. So 2 into r divided by this g is left out. So T1 into T2 will be equal to 2 into capital R divided by g. Okay. So that's what they've asked us to put, 2 into capital R divided by g. Got it?
Yes, sir.
So these are all the problems that are based on projectile motion. Tomorrow I'll explain few more problems and then we'll go to the relative velocity concept.
Okay, sir.
Okay, today's class. Any doubt from today's class?
No, sir.
Okay.
Okay.
Thank you, sir.
Yeah, see you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.